CS1010X Lecture 2 Functional Abstraction, Variable Scoping, and Picture Language. This is the rule map again. Functional abstraction here. This is on the basic part that we are going through. We saw in the last lecture how we use variables to define or associate to concepts. Now we want to abstract out works into function that we use often. This is functional abstraction. As you will realize, this is a way to help in our management of complexity in solving problems. For a simple example, let's say we want to square a number. Well, we simply key in 21 times 21 to get the square of 21. The answer is 441. Now, suppose we want to find squares of various numbers. We can just abstract this out to give it a name. We call it square. Here it is. Define is to define a function, give it a name, square, and this is the variable x, which is the former parameter, and colon to start the function body. Then you simply write return x star x. So the x is a value, for example 21 as we saw, and when you key in square 21, you will get 21 star 21. So if we type square 21, we will get 441. Now if we type square 2 plus 5, square is the function and it's going to square 2 plus 5, which is 7. So square 7 is 49. Next example, if you want to square 3 and to take the square of the square 3, you write square 3, and square 3 give you 9, the square of 9 give you 81. Now we can build more abstraction with the square that we have. For example, if you want to have a sum of squares, so we define sum of squares x comma y, these two are the parameters, colon, return square x plus square y. With the square that we had before, we can simply use it here and here, add together to get a sum of squares and return. So now, for example, you write sum of squares 3 comma 4, which is 3 is x, 4 is y, so it's square 3 plus square 4. You get 25. We can build further on top of sum of squares. We can define hypotenuse of a right angle triangle with sides A and B to be the sum of squares of A and B and taking its square root. Square root is a function inside the math library. We can now say hypotenuse of 5 comma 12 is 13. We now sum up this part of the discussion. This is the general form of the function definition. You have def, which is define, the function name. Usually we choose something meaningful so that the program is readable. And formal parameters, those values that we want to send into the function, and followed by the colon, then the body, which is indented, just like the conditional statement, right, that you want to do the computation. So the name, it's the name of the function. To repeat, this name should be chosen appropriately so that your program is readable. Formal parameters, these are the values and possibly function also that we want to pass into the function for computation. Body, it contains expression to be evaluated, and again, the body has to be indented and it can return value or function as output. So here is the look of a function that takes in input parameters and with output. We generally just need to know what it does and we don't need to know how it does it. And then the return type, it's the output. The output is returned with a return statement. If you don't have a return statement, then the return type would be none. The next slide will illustrate this. We want to see the difference between return versus print as in the function. Here we have defined square x, return x star x, which is what you saw before. If you have a equal to square 3, that means that a is being assigned the value returned by square 3. In this case, x is 3, so 3 times 3 is 9. So a 9 is returned to be assigned to a. So when you type a, you get 9. Print a will give you 9. On the other hand, if you define your square to look like this, which is square you just simply print instead of a return. You print x star x. When you put b equal to square 3, you have square 3, x is equal to 3, so 3 times 3, 9, print 9. So you have a 9 printed out. On the other hand, when you check the value of b, actually b has nothing, all right? And print b will give you none. Another way to see this is the type of square 3 here, it's actually integer because it returns square 3, which is 9. 9 is integer. For here, in this case, square 3 actually print out 9, but the type of this square 3 is actually NoneType because it returns nothing. Now we can write variables and name them anyhow. Who is who then? This is the same as in the world. Many people can be called the same name. So if within your circle of friends, if you have more than one, say Kelvin, which Kelvin are you talking about? It should be the one that closest to you or both of you. Same spirit is in computer program. In fact, you should realize after learning a programming language that programming languages often try to be as humane as possible for ease of comprehension by human being too. Let's look at some examples. X is equal to 10. We define square x, return x star x. So what is this x? Is this x the same as this x? No, this is called a formal parameter in the function. So this x, it's bound within here. And so these two x's are not the same as this x. Next, define double x colon return x plus x. Once again, this x is bound to this function, so this x appear as these two x's here, and this x are of no relations at all. And of course, this x and this x also have no relation. Next, define add x, y, return y plus x. So y is a formal parameter, so y is bound and y is here. And what about this x? This x appear for the first time, and it is not bound to this function, so this x is indeed referring to this x equal to 10. So y is bound, x is free and refers to this x. Let's look at this again. Define square x colon return x star x. So x within the parenthesis here, it's called a formal parameter. It could be more than one. Here we have just one. A function definition binds its formal parameters. That is to say that the formal parameters are visible only inside the definition or the body and not outside of the body. So in this case, the body here is just a single statement, return x star x. So we call formal parameters as bound variables. The region where a variable is visible is called the scope of the variable, i.e., the scope of a formal parameter is the body of the function. Any variable that is not bound is called free. Here is another example of a block structure. You have a function, hypotenuse, and inside this function you have another function. This is actually a local function. It's a sum of squares. So a hypotenuse of a right angle triangle with sides a, b is indeed the square root of the sum of squares, where sum of square in this case is a local function. And it takes no parameter, returns square of a plus square of b. This a then refers to the a in the formal parameter because the scope of a is within the whole function, inclusive of this local function. And b, likewise, it's referring to this b as in the formal parameter. So the variable a and b in sum of squares refer to the formal parameters of hypotenuse. In this particular routine, the sum of square it's a local function, and this is hidden from any users of this function hypotenuse. Let's take a look at an example in either. We have x equal to 2, y equal to 5, and define a function f taking in formal parameter x and z. And then a is assigned with the value x plus 1. X is assigned 7, z is assigned y plus 1. And then print out z's value and return a, which happened to be x plus 1. This statement is simply to call fyx and to print out fyx value. Let's run it and to see what happened. Run the module. We have z equal to 6 as given from this statement. Z is printed out to be 6y. Z is equal to y plus 1. What is y? In this case, y is free, so y is equal to 5 from outside. So 5 plus 1 to give you z is 6, so that's correct. And what about the print statement? Print f bracket y, in this case y is 5, so f5 comma x is 2, so 2 equal to 6. 6 comes from this value, so fyx, y is 5, x is 2, so this x is now 5, this z is 2. Okay, so x is 5 means that a is then 6, so that's why return a give you 6. What about this z? This z was a value of x and it is 2, and then is being set to become z to become 6. But actually this 6 doesn't seem to have any effect to the x that this z correspond to. Let's check it out. X is still 2, y is 5. What about z? Z is actually not defined because its scope existed only within the function. So now we are outside the function and we get an error for it. So let's try another one. Let's copy this and suppose we want to change the y outside the function. Let's change it directly. Y is equal to 8. Okay, let's run this and see what happens. Run module, save first and run. Oops, there's an error. The error says that local variable y referenced before assignment. So with the addition of this statement to the same code here, thinking that this y is actually the same y as here, then we are wrong. Because a y as somebody appearing on the left hand side of equality, right, means that this is now happening within this function. So y now is a local variable, and a local variable must be first initialized, meaning that it must be given a value before it could be used in the right hand side. So this statement causes the error. Okay, so how to fix this? So the same code, we can add a statement here called global y. What happened then? Let's see. Run. Now it works. So let's see what is x. X is 2, y used to be 5, and we say global y, so this y, any y references refer to the y from outside. So this 5 plus 1, so z is equal to 6. So let's see, z is equal to 6. Oops. Z is equal to 6 within the function, but it no longer exists outside of the function. What about y? Y is 8. Because y is equal to 8 and this y, assignment of this 8 to this y is the global y. Okay? So this example hopefully helped you to comprehend the scoping problem. To sum up this part of the discussion, we always want to use meaningful variable names. You don't save in your typing to forgo your understanding. 2, you don't overload the same variable names unnecessarily. Overloading means using the same variable name for different purposes. This is actually needed in some cases. So what we say here is that don't anyhow use it. 3, for cryptic programs such as those given in the test or exam, you can check out Python Tutor at this link to trace your code to find out if you have doubt on the variable scoping.